I'm managing our so-called Planetary Defence Office. I'm also a lecturer at the Technical University of Munich, but today we'll talk about the Planetary Defence Office of the European Space Agency. The Planetary Defence Office is part of what we call the Space Safety Program, which is a program that is in place since the 1st of January this year. But it's based on something we called space situational awareness, and the activities that I will describe today basically started at the end of 2008 already. So it's a bit over 10 years, 12 years that we've been active with this. The space safety program is structured in these 5 points that you see here. We have something we call core activities, and we have 4 space elements. I mean, we're a space agency after all. There's a space weather mission planned. There is HERA planned. HERA is a mission going to an asteroid, participating in an asteroid kinetic impact or deflection demonstration. And there are 2 missions which are in the pipeline related to the removal of space debris from space. The Planetary Defence Office is part of the core segment. And this core element contains the core activities related to space weather, to space debris, and to whatever we do related to near-Earth objects. That's what you see here. So if you can see my mouse on the left part, there are some nice slides related to space weather, which is basically, being aware of what happens mainly on the sun, because then radiation could come to the Earth and interact with Earth's ionosphere and do damage to our assets on ground. The middle depicts what we do in the NEO part, in the nearest object part. I'll come to that in more detail. We also deal with space debris. One is seeing where these fragments of spacecraft are, or complete spacecraft, and we're also preparing for active removal of these objects. Now, the Planetary Defence Office is currently has about 11 people when I last counted, plus 1 trainee. Actually, at this particular moment, we have 2 trainees because one is still there until the end of the month. The other one already started at the beginning of the month. Our main location is at Esrin in Frascati, Italy, not far from Rome, actually very close to ASI, to the Italian Space Agency also. In addition to these people, of course, most of the work following ESA rules is actually done external to ESA with contractor companies, which we use for hardware and software development. And we also have support from other parts of ESA. You see that in the structure to the right. We structure ourselves in 3 what we call pillars. Pillar number 1 is observations. So we look at asteroids. We have to find them before they find us. Somebody may remember who said that. The second part is information provision, which comprises also the determination of the orbits of the objects and impact monitoring. So we predict orbits 100 years into the future and then find out whether they collide with the Earth or not. And the last pillar is called mitigation. Mitigation means to me to reduce the risk or the damage that we could get from an asteroid impact. So that's both informing, for example, emergency response agencies, and it also includes deflection. And so I said the HERA mission itself is basically a separate element which comes in addition to the work that we are doing. And the support from other parts of ESA is mainly reflected in this ground base plate that all these pillars are standing on. We call that Planetary Defense Ground Segment Infrastructure. Well, there we have ICT services, computer services. We have people that do software testing. We have people that help us with the optical design of telescopes and things like that. So there we use all the expertise that we can find in the European Space Agency. Most of the team of our core team is located in Esren. I mentioned this before. There we have something we call NEO Coordination Center, which in the beginning was more a computer room than a real center, but it's being reconstructed as we speak. So the official inauguration was done by the director in those times of operations, Thomas Reiter, and the Italian delegate to SSA, member of ASI here. And this is the building as it looks now. You see a lot of construction work. To the lower right, you see basically they tore out everything that's inside. And we will get a nice new interior with lots of windows and light and green plants if you follow the architect. And then we can have most of the team in a dedicated building at Esren in Frascati. So let's go through the 3 different pillars and quickly look at what we are doing. I basically want to give you an overview of what we're doing, nothing more, because you know, some of you may look for a job in the future, and we are expanding. We're still expanding, and we plan to grow even more depending on funding availability. So maybe it's good that you know what we're doing. In terms of observations, we currently follow up or concentrate on follow-up observations. We use a number of different telescopes, some of them only during new moon, other telescopes we have fully available for us. We also use, for example, the VLT, which is the very large telescope of ESA. It's an 8-meter telescope where we have observing time to look at, in particular, the very faint asteroids, and we have an agreement with them that we don't waste observing time. We focus on objects fainter than 24 magnitudes, which are on our risk list. So that means they do have a computed probability larger than 0 to hit our planet. And currently we have 11 hours every semester. That's sufficient for the state we're in now. If we increase our survey capabilities, probably we need to increase that time too. Physical properties, I want to mention that here, even so we don't really do very much. We really focus on astrometry, on the orbit determination, or astrometric observations to allow orbit determination. We look a bit at physical properties. We'll start some regular light curve observations, and we have a contract running with our colleagues from Space Dice to look at radar capabilities in Europe. That we're planning to do some parallel observations with our American colleagues beginning of next year. There's a lot of, there's funding, I'm not sure whether a lot, but there's funding from the European Union for the NEOCC project, where you heard a presentation yesterday. And that's why we sort of say, okay, let's not duplicate work here, but make sure everything is covered. Most important one, of course, is survey. We currently still rely on the American-funded, NASA-funded activities in terms of surveys like Pan-STARRS, like the Catalina survey or Atlas. We are building a telescope which is almost there, which is a 1.2 meter telescope, which has a very wide field of view. 6.7 by 6.7 degrees field of view, so that's about 130 times the apparent size of the moon. So that's quite a lot, but we are not yet there. We're just doing test phases, like with the Calle Alto Schmidt now. We started some really low solar elongation surveys and things like that, just to get a feeling how to do surveys, but we need to wait for our Fly-Eye telescope, and I think I'll have a dedicated slide for that. I should note that all the images that we are maintaining are made publicly available. If you go to our webpage, there is, I think, a link coming later. It's simply neo.ssa.esa.int. Then you can access all the images. You don't need to access them to look for asteroids. We've done that, but they may be relevant for other search activities. And I put that in the green part here. You can access the images even via a search interface provided by the Canadian Astronomy Data Center. These are the telescopes we are working with. All the color codes mean something. I think the green means it's really under direct or the full funding of ESA. and the others are just collaborations. So, but you can see that, you know, it's important to have a network of follow-up telescopes. That's what the coordination in NEO Coordination Center says, that we are really focusing on that aspect. If there's an object that needs follow-up, we try to contact telescopes, and we have contacts all across this planet. Just to give you an example of some fun stuff that we're doing, and also how closely related our work is with the work of our Space Debris Office colleagues. We, just as a test case, did a coordinated observing campaign to look at the Bepi-Colombo Earth flyby. Bepi-Colombo came by to something like 19,000 kilometers distance in April this year. And I actually just see that I have a typo here, but okay. This is something we need to fix. The Bepi-Colombo Earth flyby was measured with optical telescopes from our coordinated team, and we compared it to what Flight Dynamics measured. And the good news is that we are really close, and you see there's a typo here. Either this is 10,000 or this is 19,000. I have to check this. One of them should be, these should be the same digits here. So the flyby distance we could actually pin down to about 100 meters, which is well within 1 sigma of our error bar. The flyby time we pinned down to 20 milliseconds, and we also could pin down the area to mass ratio to about, I think this is about, better than 10%, definitely 5%, something like this. So that's good news. I mean, it shows that we can, using optical observations, get very good accuracy on the position of an imminent impactor. Bepi-Colombo came from the sun side and flew out away into the night sky. We have a paper submitted to Icarus, and there we basically turned it around and said, okay, what does it mean if this thing were flying the other way around? I mean, it's symmetric, so it shouldn't change anything. And then we assess the accuracy of our observations. That's an interesting work there, where we use spacecraft to help us understand what we are doing. We also look at smaller stuff. We have a few people that work on fireballs, mainly together with the University of Oldenburg. They set up a system called Near Real-Time Earth Impact Monitoring System, which tells us whenever on this planet a fireball was reported in social media. That's super handy for me if, you know, a reporter calls and says, oh, I heard there was a fireball in southwestern China or wherever. Can you say something about it? Then I say, yes, I can, because we already know before everybody else. Well, not everybody else. Somebody must have tweeted it first, but that's an interesting thing. And we were building up interfaces with the CTBTO. That's a system of infrasound sensors. So it's basically microphones that measure sound below the threshold of what you can hear. And there's a network all across the planet which was set up to monitor nuclear explosions, illegal nuclear explosions. They also detect fireballs, and we can now, whenever there's a fireball coming in, immediately check the infrasound data, and that gives you a very good feeling for the kinetic energy that was generated there. So that's one of the services we currently provide via the webpage of the International Meteor Organization. These data are distributed. A bit to the FlyEye telescope. We are currently negotiating a site loan agreement. We are finalizing the dome and the infrastructure. You see a sort of a mosaic of the telescope to the right. The mount is currently still in Luxembourg. That's the white part down here, because it was built there, and the telescope itself was built in Italy at OHB, and I just took the top part here, which will then end up off the mount. So this is how the complete thing will look like. And the idea is to install it at Monte Mufara, which is in Sicily. The idea was to be not too far from the company which builds it, so, and it's of course good to have something in Europe. This is a view here. It's really a nice area. There was a site visit last weekend where I saw some very nice photographs. We currently have what our experts call suboptimal PSF, which is currently being investigated. There are 16 separate cameras and 16 separate optical channels, and we are currently testing 3 of them, and 2 of them weren't as focused as they should be. And then by swapping around things, you can test what the problem is there. So they're doing the technical work to really get the telescope working, and then hopefully sometime next year, we'll see first light with the telescope. This is a CAD drawing, a computer drawing of how the building will look like. It looks very similar to the Vera Rubin survey telescope building. It's because the same company is building it, only ours is much smaller. Information provision, we look at the orbit software. We evolved our software from the NEOCC system that has been mentioned several times already before, but it's basically completely rewritten, and we expect to switch from the current NEOCC system to our own software. Well, it's, like I say, it's the same software written by Space Dice before the end of the year. We are updating our web portal right now. If you go to the portal, it looks a bit old-fashioned. Well, it will be nice and shiny very soon. And we have a system running called MeerKAT, which is a software tool that takes tracklets from the Minor Planet Center for objects in the NEOCC, and then we use systematic ranging to identify imminent impactors. And some screenshots here. This is how our new web portal will look like, and here you'll see the link also for your reference. Like I say, right now it looks a bit more old-fashioned. This is the MeerKAT system. Here you see the little MeerKAT being on watch for asteroids or bright meteors. And this gives us a very nice overview of whether we have any objects being immediately threatening. And then I get this nice dashboard with all sorts of information on which lets me judge whether this is something we need to be worried about or not. Last point is mitigation. We are working on a few things. We are iterating a lot, in particular with the German, what they call Weltraumlagezentrum. So it's the German Center for Space Situational Awareness. They are helping us a lot, but in the end, we are building up interfaces to all ESA member states, where we set up a system that we can inform them about, you know, close flybys, things like that. They want to be informed, in particular in Germany, for example. They want to know they have troops stationed close to Afghanistan, as an example. And, you know, if we know that there is an asteroid predicted to impact over Afghanistan, even if it's a small one that just generates a fireball, they want to know, just to be sure that nobody presses the wrong button. So there's some interesting use cases there for the information that we provide. One thing we're currently focusing on is we're developing, or have developed, a knowledge base for impact effects. So we had a science team looking at what happens if asteroids enter the Earth's atmosphere. There's plenty of detailed scientific publications around. They put it all together, and now the next step is that we need an operational tool. So suppose I have a predicted impact, I want to be able to press the button and then get a good estimate of the possible effects of this object. And I don't have time to run a 3-week detailed numerical simulation. I need to get some information quick. And that's what we're working on right now in this area. We are distributing, for example, information about close flybys in this form. We generate something called Close Approaches Fact Sheet, CAFs. And this is one for a recent asteroid 2020 OY4, where, you know, you get the most important information on 2 pages. If there were an impact solution, there would be a 3rd page which would show the impact corridor. That 3rd page we do not make public right now. We would only distribute the emergency to the emergency response information, response agencies. That's stuff that's being discussed also on higher level, on an international level with the United Nations, what to actually distribute in terms of information. And that's an important part. The work on, say, United Nations level, there are 2 working groups. One is called International Asteroid Warning Network. the other one, Space Mission Planning Advisory Group, where we are active. And I think with that, I can just say thank you for listening. I hope you got a bit an overview of our activities. Remember, what we're doing is part of the Space Safety Program Period 1. We expect new budget in January 23 to continue the work that we are doing. And I did not mention at all Hera because, as I said in the beginning, this Hera asteroid mission is a separate element. So I really focused on the core tasks of our Planetary Defense Office. With that, I'm open for questions.